So this is week 3's weekly activities in term 2, and the focus this week was measurement. And the activity actually included these helpful steps at the beginning regarding how to do a measurement question if you're not sure and you can't see the way to calculate it. And the key things that I just want to highlight before we get into the questions is the first thing that they say is determine the unit that the answer must be given in, right? And the units become important because one of the most common errors we see is people start with a question where there's measurement and there's centimeters and millimeters in the same question. And as soon as you try and calculate those together, then it's a breakdown because you can't calculate a centimeter with a millimeter. They both need to be the same. So the most important thing to start off with is checking your units and doing conversions. Get everything into the same unit first before you go any further. If you can move everything into centimeters, do it. If you have something with like area and length in it, where you've got cubic and square units as well as normal units, you need to get them into the same version of the unit. So centimeters squared with centimeters cubed. You don't want to have millimeters cubed with centimeters squared. That makes it very difficult to work with. The other thing they say, step 3, is then substitute into the correct formula. So this is kind of your golden rule. If you don't know what else to do, just take the formula they've given and rewrite it with the values you know filled in. That in and of itself gives you a substitution mark. And it can help give you a starting point also for what to do next, or what are we looking for in order to make the next step. Okay. Then we've got calculate the missing amount, and then check your answers are correct and rounded as your final checkpoint. Okay, so let's go to question 2.1, our first question here. And we've got here the dimensions of a 20-liter paint bucket are shown below. The diameter of the paint bucket is 332 millimeters, and they're loaded into buckets below to be transported. You can see there we've got an image of the bucket. We've got an image of the buckets when they're all paint, all on the palette there, and they also give us this little conversion over there about liters going into centimeters cubed. So the fact that that's there tells you already you're probably going to need to use this conversion at some point. So the first question tells us here, and it is a higher order question, the salesman states that the height of the bucket is 30 centimeters. Verify using calculations if his statement is correct. You may use the following formula. Volume is 3,142 times radius squared times height. And hopefully you do recognize this 3,142 is pi. Okay, so remember what we said. We first need to check are our units going to be the same, and then we need to fill into our formula. So if I look at my formula, I have 3 unknowns at the moment. I need the volume, radius, and height. Well, height we know is kind of what we're looking for, so that's going to be the one we don't have. But you should be able to find the other pieces of information, because if you have a formula, you should have every piece except the one you're looking for, or be able to find the other pieces. So height we're going to kind of ignore for now. We need to look for our radius and our volume. So radius, what do we know about it? Well, we know there's a diameter over here. So from a diameter, we can get a radius. So let's look at this. We also notice the diameter that we're given is in millimeters, and they're asking me height in centimeters. So we're going to need to convert. So let's do that first. I'm going to just pop it over here. We're going to say 332 millimeters is going to be dividing by 10 to give me 33,2 centimeters. That's my diameter. And then if I'm going to change that into a radius, I'm going to need to go and say, well, what is 33,2 divided by 2? Because remember, diameter is the whole way across. We only want halfway. And if I do that, I get to 16,6 centimeters. Okay, so that's our starting here. We know our radius now needs to be 16,6. And we're squaring it because the formula tells us to square it. The other missing value that we had was the volume. Now let's see what we know about volume of this bucket. Well, they do tell us that this is a 20-liter paint bucket. Okay. And anything to do with capacity has to do with volume. They also tell us 1 liter is 1,000 centimeters cubed, and we should know cubic units relate to volume. So we can change 20 liters into centimeters cubed, then we'll have a volume. So if I do that, and I'm just going to work up here by this, I'm going to say 20 liters times by 1,000 gives me 20,000 centimeters cubed. Okay, and you're always showing your units. Right, now we can start filling in our formula, and I think I'm just going to go onto a new page for that. Okay, so what we're going to do now is, firstly, I'm going to write out my formula. You don't get marks for writing out a formula that's given, but it's helpful to make sure you fill everything in. So volume is 3,142 times radius squared times height. My volume we now know is 20,000. 3,142 is just a number. Our radius we know is 16,6, and we're squaring that. And the height is the unknown. Right, now we have a formula where we've got things we can actually calculate with. So the trick now is we go and we say, okay, what can I calculate right now in my formula? Well, I know how to square 16,6. I also know how to multiply numbers together. Now, BODMAS should tell you we always square first. So I'm going to do that, and I'm going to say 16.6 times 16.6, or you can say squared if you've got a calculator, gives me 275,56. So I'm going to leave everything exactly as it is, which I haven't done anything with. 3,142. I fill into 275,6 times height. Okay, you may be asking yourself, do you have to show these separate steps, or could you also straight away multiply that with 3,142? And you can just do that, but it's always good to show your steps in case there's a mistake somewhere. Then your marker knows you can kind of continue on and just penalize your 1 mark. Okay, I get 865,80952 times by height is 20,000. Now this is the point where you hopefully can recognize, or you will recognize now, that I've got a number times by the height gave me this 20,000. So the question is, what times this gave me that 20,000? And we can work that out by dividing. This is a very similar concept as when you say something like, it cost me 50 Rand for 10 items. How much was each item? And so it would be 10 times something gives me 50 Rand. Well, we know we should be going 50 divided by 10 to find out what the Rand value is. This is that very same concept, but just with more complicated numbers. So all we're going to do here is say, well, my height then should be, if I divide 20,000 by 865,80952. And remember, we don't cancel things on our calculators when you're in the middle of a calculation. Okay, so I'm going to go 20,000 divided by 80952. Okay, if you've got a scientific calculator, you could have also just said divided by the answer, and I get 23,099, and it kind of keeps going after that, but for purposes of what I need, I can just then round that and say it's approximately, and we check if it tells me what to round off. Okay, so it just tells me we're not actually needing to round off, because it says, he says that the height of the bucket is 30 centimeters. Is he correct? Well, no, because it's not 30 centimeters. It's 23. So we write our conclusion statement that he is not correct. Okay, because it's less than 30 centimeters. If they were wanting to know the actual height, you could at this point at your end of your calculation round off to say 23, 1, but it's not necessary to be able to answer the question at this stage. Okay. There was an alternative way because of how the question was being asked. You could have also calculated volume using 30 centimeters in your formula and then figured out, does it give you the volume of 20,000? That would be an alternative way of working it. I'm not going to show that one now because although it's legitimate, there are ways to ask this question where they will force you to work backwards. So it's quite important that you do know how to do this type of a calculation. Right, let's look at number 2. So question 2.1.2 starts with calculate the total volume of the paint on the palette in kiloliters. Okay, so this one is quite nice because it doesn't follow on from our last question, although you might be mistaken in thinking it does because it does reference volume, but it also referenced that they want it in kiloliters, and we already know the volume in liters, so that makes it quite easy in that sense. So the first question is, well, how many tins of paint are there on the palette? And this is basically just counting, right? You can count and see there's 1, 2, 3, 4 going along. There's 3 rows of 4, so there's 12, and there's 2 levels. So there are 24 tins or paint buckets on that palette. We know each paint bucket is 20 liters, so we're just going to go 24 times 20 liters, and that will give us 480 liters. And they do want it in kiloliters, not liters, so we need to convert, and we can go 480 divided by 1,000, because there's 1,000 liters in a kiloliter. Kilo always means 1,000. And I get to 0.48 kiloliters. Okay. Question number 2.2 talks about the palette, and they tell us it needs to be shrink wrapped to transport it to the stores. They give us the dimensions, and they tell us, note that the shrink wrap is the plastic used to cover and protect goods for transport. And the first question there is, determine the total height of the palette and the 2 paint buckets as indicated on the diagram. Okay. So this question is actually asking you about using your previous answer, because our previous answer told us the height of the tin. So in question 1, we established the height of one tin was 23.1 centimeters. And in this case, we have 2 tins, and they also tell us the height of the of the palette. So all we need to do for this one is add them together. We got 23.1 times 2, or you could just add them. And we also add the palette height of 14. This is all in centimeters. So we can just go and say, well, what does that equal to? So that's 46.2, which will give you 60.2 centimeters. Next, they ask us to calculate the total surface in meters squared of the palette and the paint buckets that need to be shrink wrapped, and they give us a formula. Okay, so the important thing we want to notice with this is they're wanting it in meters squared. That tells us all of the measurements that we put into our formula needs to be in meters. So the length I have is in meters, the width I have is in meters. The only thing that's not in meters currently is my height, and I'm just going to need to convert that to meters. So I'm just going to take what I had as centimeters, divide by 100, gives me 0.602 meters, so I know to use that. Then this is quite a straightforward question. You go and you fill it in to your formula. So I think I'm going to just do different colors to make it easy to see what I'm doing. So I've got a length of 1.4, so wherever I see length, I'm going to put 1.4. So there it's twice, 1.4. My width, let's go with a nice red full width. Width is 1, so we can put a 1 wherever I see a width. And then my height, I'll go with the blue I used earlier, 0.602 and 0.602. right? And then we can just fill in all the other parts of our formula. So it's 2 times this plus 2 times width times height plus 2 times that times width, right? So you can see what I did there. I literally took my formula and I just filled in all the different values. And then when you calculate that, you can put that into a calculator as it is, and you will get to 5,69 meters squared. Because it's surface area, so surface area is always squared. Okay, 2.2.4, the paint needs to be stored in a warehouse. Determine the floor area that 6 pallets will occupy in the warehouse and round up your answer to the nearest meter. And they give us a formula of areas length times width. So this is quite straightforward again. They want our answers in meters. So that tells us that everything needs to be in meters, but the good news is the length and the width was in meters already. So all we're going to do is the area. The length of the pallet was 1,4. The width of the pallet was 1. So the area of one pallet is going to be 1,4 meters squared. But we don't have 1, we have 6. So we need to take that answer, 1,4 meters squared, and we need to multiply that by 6 of them. And when we do that, we get to 8,4 meters squared. And then very important, they do tell us to round up our answer, so therefore we can say approximately 9 meters squared. Okay, and that was nice because it's quite a lot of marks for what is relatively a straightforward question. Alright, question 4.1.2, so this is actually unrelated to the earlier questions from the numbering. And they tell us here the actual height of glue in a put container is 8,5 centimeters. The volume, rounded to 3 decimal places, is 52,346 centimeters cubed. Determine, rounded to the nearest gram, the mass of the glue in the put container if the density is 0,82 grams per centimeter. Now, you might be thinking, what are we talking about density? We don't have density, and we don't really deal much with density in Mathslit, and that's true. But we do deal with formulas, and part of Mathslit is applying what you know into an unfamiliar context, and this would constitute an unfamiliar context. But you know how to substitute, and we know how to work backwards with a formula. It's the same like we did in question 1, and we do with speed, distance, time. So, you're given a formula. First thing you want to do, fill in everything you know about the formula. So I'm going to do that in my space over here. I've been told density is equal to mass over volume. Currently, I know that the volume of the glue is going to be, let me do this a bit neater here. I know the volume is going to be 52,346 centimeters cubed. I don't know what the mass is, but that kind of makes sense because that's what they're asking me to find. And I know the density because the density they tell me is 0,82 grams per centimeter. So the important thing here is to remember then that if the density is in grams per centimeter, mass will have to be in grams, and therefore the volume needs to be a version of centimeters. Okay. So, and it is already, so I don't need to convert. So now the question is, how do I find the missing value? Well, we're going to work backwards. Something divided by 52 gave me this 0,82. So I multiply to find the missing value. I'm doing the opposite. So that means I can say, well, therefore my mass is going to be 0,82 times by 52,346. And if I calculate that, 42 0.923, and it kind of continues. We know this should be in grams because we know the density was grams per centimeter. And they do tell us in the question round off to the nearest gram, so I can therefore round that to 43 grams. Okay. Question 3.1 is all about irrigating a sports field, and there's a water cart over there. They tell us the tank is 2.5 meters long, the diameter is 150 centimeters, and they also give us formula. So our first question is asking us to determine the radius of the water tank. This is quite straightforward because we have our diameter of 150 centimeters, and hopefully we realize if diameter is the full length across, radius will be half of that. So all we're going to do is say our 150 centimeters divided by 2 is 75 centimeters. Then they say calculate the amount of water in liters when the tank is full. Round your answer to the nearest liter. And it's 6 marks, so that tells us it's going to be quite a bit of a calculation. So if we're talking about amount of water in liters, let's see what we know about liters in our question. Well, we told liters is 1,000 centimeters cubed. That means it's going to relate to volume because it's centimeters cubed, not squared. So that tells me I'm going to need to use my volume formula as well. So we follow our normal process of first writing out the formula. Volume is pi times radius squared times height. Fill in what we know. Well, this time we're looking for volume, so we can leave the volume out. Pi is 3,142. Radius we had was 75 centimeters, and we're going to square it. And then the height of the tank, well, we know that the height of the tank is actually, in this case, length from the diagram, and it's 2,5 meters. Now I can't put 2,5 meters straight into this formula because it's in meters. I need to convert and get 250 centimeters. Then I'm going to put it in my formula, calculate that out, and I get 4418437, 5 centimeters cubed. And then we need to convert it to liters because they want our answer in liters, and we can see it's 1,000 centimeters cubed to a liter. So we're going to just divide that. 4418437, 5 divided by 1,000 gives me, and they want it to the nearest liter, so that means I can round it to 4418 liters. Alright, question 3.1.3 is asking us that the tank is made of a sheet of metal. Calculate the amount of metal that is used to make a water tank. And rather important here, they do tell us it's in meters squared, which should be your hint that it has to do with area or surface area in this case. And we have a formula for surface area over there. So all we're going to do, fill it all in. The important thing here is the fact that they're wanting it in meters, which tells us all of our values going into that formula should already be in meters. So let's see. We've got surface area is going to be 2 times pi times radius times by radius plus height. So let's fill it all in. 2 pi we know is 3,142. Radius we know was 75 centimeters, which is 0,75 meters. Brackets, again, 0,75 meters, times by the height, and the height they tell us is 2,5 meters. Okay, and that gives us 15,317, keeps going, meters squared. Okay. Question number 3 now asks us about a sprinkler that's used to irrigate at the sports field. They tell us that it distributes water at a rate of 12,5 liters per minute. On a certain day, the gardener is started irrigating with a full tank. After some time, she noticed that the water in the tank was halfway mark. For how long did the irrigation process take place? Give your answer to the nearest hour. Okay, so let's break down what we have here. We have the sprinkler rate of 12.5 liters. No, it's not a highlighter. 12.5 liters per minute. Okay, and we know we were going from a full water tank to a half water tank. So the question is, how much water was used in that time? And then we can figure out how many minutes that was. Okay, so how much water was used? Well, how much water was in the tank to begin with? And if we go back to our question, we had previously calculated the volume in question number 3.1.2, and that was 4418. So let's put that in there as our value at the full tank. So we have 4418. That was a full tank. If we've used half of it, we halve that. We get to 2209 liters. And now the question is, well, how long did it take for 2209 liters to be used? And we know it was 12.5 liters per minute. So I'll just use the space over here. So I've got 12.5 liters for 1 minute. I need to know if I have 2209 liters, how many minutes it will be. And some of you will see this and go, I can just divide. Some of us prefer to use a ratio and go, well, I'm going to divide up and then multiply across. Both methods will work. And you'll get to 176.72 minutes. Now, the other important thing with this question, and hopefully you're highlighting when you're reading your questions, is that they want it into the nearest hour. So we now need to convert. So all we're going to do is take that 176.72 divided by 60, and it gives us approximately 3 hours when you round off. Okay. Right, 3.3 is a little bit of probability thrown in, because probability can be brought into all parts of your paper. We're told the sports fields are not irrigated on rainy days. On one evening, the weatherman predicted that there was a 0.75 chance of rain the next day. They want you to write this as a percentage. Well, a decimal as a percentage is not too difficult to do. You're just going to times by 100. 0.75 times by 100 is 75%. Okay. Remember, decimal is a type of fraction. We know to change a fraction to a percentage, we times by 100. We do the same thing with a decimal. Then we're told, determine the probability as a common fraction that the sports field will not be irrigated the next day. Simplify your answer. So they tell us that they're not irrigated on rainy days. So all we're going to do here is say, well, we know that the chances as a percentage was 75%, but they want this as a common fraction now. So changing to a fraction, 75 over 100. Simplify, which you can either divide both by the same value, in this case 25. So dividing by 25 on top, dividing by 25 on the bottom. Remember, if you have a calculator, you could also just put the fraction in the calculation, say equals, and it will give you 3 out of 4. And that's the simplest probability. Right, that is the end of week 3.